This is lesson AMU2L4, and we're going to talk about symmetry and even and odd functions. So first let's start with symmetry. We're going to look at two different kinds of symmetry. Now, having symmetry is when something can be cut into two identical parts. So the first type is line symmetry. And with line symmetry, your graph could be folded along a line so that the two halves match. Like this graph could be folded right here along the x-axis and the two halves would match. This one we could fold along the y-axis. The other type of symmetry is point symmetry. And in point symmetry, the graph remains unchanged, or rather it looks identical when it is rotated 180 degrees about a point. So if I rotated this graph 180 degrees, it would look just like it did in the beginning. Now, the x-axis and the y-axis are common lines of symmetry, but they are not the only ones. The origin is a common point of symmetry, but it also is not the only one. Now, it's hard sometimes to just look at a graph and tell if it's symmetrical, so we have tests. We have graphical tests and we have algebraic tests. So, let's look first at the graphical test. For every point x, y on the graph, there is also a point x negative y. Now, what does that look like? Well, let's just take the graph we had above this that we said was symmetrical, the sideways parabola, and let's pretend that we could pick 2 points on here, and let's look at the ordered pairs for those. This point would be 1, 1, and this point would be 1, negative 1. That's what it means by this would be positive xy, and this is x negative y. All right, what about for the x-axis? For every point xy on the graph, then there's a point negative x positive y. So let's just look at that absolute value graph that we had up there. And if I could pick 2 points on it, and let's also use the 1 and 1. Now this point would be positive 1, positive 1. What would this point be? It would be negative 1, positive 1. So that's what it means by xy and negative x, positive y. Now, for the origin, for every point xy on the graph, there is a point negative x, negative y on the graph. And let's think back to that example that we just had up there. We had a graph that looked something like this. So if I picked points here and here, and let's use 1 again. All right, this point would also be 1, 1. Now what about this point? Well, it would be negative 1, negative 1. So that's why it says xy is matched with an negative x, negative y. Okay. Now, as far as your algebraic test, when you have the function, you can replace y with negative y and get an equivalent equation. You simplify it down. For symmetry about the y-axis, you replace x with negative x. So it's kind of like when you were doing finding your x and y intercepts, you replace it with the opposite letter. It's the same thing here. For x-axis symmetry, you replace the y. For y-axis symmetry, you replace the x with negative x. All right, for the origin, you're going to replace the y with negative y and the x with negative x and see if you get equivalent equations. Okay, so let's look at some examples. In these examples, we're going to use the graph to determine if the relation is symmetrical, and then we're going to confirm our answer algebraically. So when we look at this graph, if I look down the y-axis, or if I split that down the y-axis, it would form mirror images. So it is symmetrical to the y-axis. Now, how can I confirm this algebraically? Well, for anything that is symmetrical about the y-axis, I should be able to replace x with negative x. So let's come up here and we're going to rewrite this. Everywhere there's an x, I'm going to put a negative x, and then I'm going to simplify it and see if it matches the original equation. Well, negative x to the fourth power would change to positive x to the fourth. Negative x to the second power would be positive x squared, so I would have 4x squared. Is this the same as my original? Yes, it is, so it checks. Now for number 2. I see that it is not symmetrical along the line of x or y, but I do notice that if I took the point at the origin and rotated this 180 degrees, it would make identical graphs. So it's going to be symmetrical about the origin. Now, how do I check this algebraically? Well, you take your original equation and you substitute negative x for x and negative y for y. So if I put negative x times negative y equals 6, negative times negative would be positive xy. This does match my original, so it checks as symmetrical about the origin. So number 3, it's not symmetrical about the y-axis, but it is symmetrical. If I cut it right here along the x-axis, then it does make two halves. So this is going to be symmetry at the x-axis. Now, how do I check this algebraically? Well, I'm going to insert, since it's x-axis, I'm going to insert the negative y. So if I rewrote this as 4 times x plus 3 squared plus negative y squared equals 16, negative y squared just makes y squared. And this would all remain the same. So does this match your original? Yes, it does. So that one checks. Okay, when I look at the graph of number 4, I see that if I rotate this around the origin, it does make the same graph. So it's going to be symmetric according to the origin. Now, how do you check that algebraically? You insert negative x and negative y. So I would rewrite the original equation as negative y squared minus negative x squared equals 1, and then simplify. Negative y squared makes just positive y squared. Negative x squared makes positive x squared. And this does match my original. Okay, when I look at number 5, is this symmetric to the x-axis? And no, it is not. If I flip it, it's not going to make the identical graph. Is it symmetric to the y-axis? No, it is not. And is it symmetric to the origin? No, it isn't. Now, it actually has some symmetry here at the point of 1, but we're not given that option. So the only option we have is it symmetric at the origin? So this is just going to be a none. Not that it's not symmetrical, it just doesn't meet any of the choices that we have. So now let's look at number 6. Now remember, these are the only choices that you have. X-axis, y-axis, origin, or none. So with regard to the x-axis, no, if I flip this, its symmetry line is not at the x-axis, so that's no. But if I flip it at the y-axis from side to side, I do have symmetry. So that's going to be my choice. Now, how do you check this algebraically? Remember, to check for the y-axis, you let x be negative. So I'm going to insert negative x, and then I'm going to simplify to see if this makes a true statement. So negative x, the absolute value of it is just x. So I got that negative sign, minus 2. All right, up here, if I simplified it, the absolute value of x is x. So I have negative x minus 2. And these two things do match, so that's a check. Now let's talk about even and odd functions. A function is even if it is symmetric with respect to the y-axis. Now this is a definition, and you just need to memorize. A function is odd, we call it odd, if it is symmetric with respect to the origin. All right, to check it algebraically, if you can insert negative x into your function and then simplify it, and that matches your original function. This always represents your original function. then we say it's even. If you substitute negative x in and it is equal to the opposite of your original function, then we say it is odd. Okay, and this will be easier to see in practice. So let's get down here to these examples. Now, what we're going to do is first we're going to find f of negative x, because that was the test for both of them. What you get when you do this determines whether it's even or odd. If it matches f, your original function, or if it matches the opposite of your original. So first, let's go to number 7. I want to find out, I want to know, what am I looking for? So what is negative f of x? Well, that means negative of whatever was over here, x cubed minus x. And what would that be? Negative x cubed plus x. So when I substitute negative x into this, I should get either this or this, and that's going to determine it. All right, so f of negative x is equal to negative x cubed minus negative x again. Now let's simplify. Negative x cubed, anytime you cube something negative, it remains negative. Negative times negative is positive x. All right, now which one does this match? Well, it matches this one over here. So that means it is odd, which means it is symmetric about the origin. Okay, let's look at number 8. So I'm going to find what negative f of x is first, so I'll know what I'm looking for. All right, if I change everything over here, or if I put a negative in front of everything over here, and then simplify, that's going to give me positive x squared minus 6. So I'm going to get one of these two things, or hopefully. If I don't get either one, then that's just a none. So let's hope we get one of the other. Now, to test it, I'm going to insert negative x in for this. So I have negative x squared plus 6. All right, negative x squared is x squared, and then that negative here. So I have negative x squared plus 6. Which one does that match? It matches my original. Therefore, it is even with symmetry about the x-axis. Now let's look at number 9. Once again, I'm going to find negative f of x by doing negative in front of this whole thing. So that's x cubed minus x squared minus 2x. And what's that going to do for me? Well, it's going to be negative x cubed positive x squared plus 2x. Now let's substitute negative x into our original. So I have negative x cubed minus negative x squared minus 2 times negative x. And let's simplify. A negative cubed is negative x cubed. A negative squared makes positive x squared, so that's going to be minus x squared. And then minus 2 times minus x is plus 2x. Okay, so which one does this match? Neither one. So this is none. Okay, for number 10, once again, I'm going to find negative f of x by saying negative of square root x squared minus 4. And that's just going to make it negative square root of x squared minus 4. Pretty simple there. Okay, let's take f of negative x and let's fill it in. So I have negative x squared minus 4. Negative x squared is just positive x squared. All right, which one does this match? Well, it matches my original, therefore it is even, symmetrical about the y-axis. Okay, for number 11, first I'm going to find negative f of x by doing negative of everything that is there. All right, a negative times a negative is going to be positive. So negative f of x is positive 8 over x. Now let's substitute negative x into our function and let's see what happens. I'm going to have negative 8 over negative x. Negative over negative is positive. So which one does it match? Well, it matches the negative f of x. Therefore, it is odd and it is symmetrical about the origin. So let's look at number 12. First, I'm going to find negative f of x. So that means I'm going to do negative absolute value of x plus 1. And that's all I can do there. Now, my next one will match one of these two or nothing if it's not symmetrical. So I'm going to do f of negative x. That's going to give me absolute value of negative x plus 1. I also can't simplify this any because I can't get it out from, since there's a variable inside the absolute value, I can't take it out of the absolute value. Now, does it match either one of these? No. So it is not symmetrical. Just put none.